Welcome to Alpha 2. This is for Unit 3 Rational Exponents. I'm going to quickly start it because I don't have time. I'm going to put all the videos right now for this, all of this in this video itself. So first things first, whenever you have negative exponents, people would think that the negative just comes outside. That is not true. When you have a negative exponent, it turns into a fraction, and there is only one of this question that has a fraction in it, and it's c. Now, I do just want to talk about this as well. If you have a denominator, it becomes a radical. So, what is the denominator here? It's 3. So that 3 goes outside the radical, that 4 stays as it is, and the negative makes it a fraction. So it's 1 over cube root of 7, 4. Now, this thing, thing about math is that you can do everything separately. So, forget x to the power of 15 and y to the power of 4. Forget it exists. What is cube root of 8? Cube root of 8 is 2. So I can eliminate c and eliminate d. Now, here's the thing. When you have, remember how here whatever is in the denominator becomes the radical? The opposite thing happens. If you have a radical, it goes in the denominator in the exponent. So 15 divided by 15 divided by 3 is 5. That eliminates this. You're left with b. Simplify the following expression. So to simplify this, again separately, 6 divided by 3 is 2. Now when you're dividing this thing, you're gonna have to subtract the exponents, right? So you will get x to the power of 1/2, and this becomes y to the power of 3/4 minus 1/4, which is just 5 to the power of 2/4 or 1/2. Right, so this is y to the power of 3/4 minus 1/4. Since we're subtracting, that's 2/4, basically 1/2. Which of the following has the greatest value? Well, this is just 0.5. 1/2 is 0.5. We say that when you have a negative exponent, it becomes a fraction, but it's already a fraction. You don't have to do anything, just bring it up in the numerator and becomes positive 1. So it's 2 to the power of 1, just 2. Anything to the power of 0 is 1. Now, this is square root, right? So 1 over square root of 2. This is not going to be greater than 2. 1 over square root is going to be less than 2. So my answer will be B. Its greatest value is 2. Moving on to the next one. Select all expressions that are equivalent to 8 to the power of 2/3. So I'll do this separately. So first things first, 8 squared is 64. 64 divided by 3, 64 to the power, cube root of 64 is 4. That's what I meant. So anything here that says 4 is my answer. This is square root of 64 is 8. 8 cubed is not 4. This is not possible. Cube root of 8 is 2. 2 squared is 4. So B is one of them. 2 squared is 4. But that's also one of them. 8 squared is 64. Cube root of 64 is 4. So D is also one of them. Cube root of 16 is not 4, so it's not that. What are the solutions to the equations below? So when you're given a radical solution, you must isolate the radical if there is only one radical. Meaning, first step, subtract 1. X plus 1 equals square root of 7 minus 3x. And then square both the sides. Now, one thing I've seen people doing is that x plus 1 squared, they would say it's x squared plus 1. That is not true. X plus 1 squared basically means x plus 1 times x plus 1. And you list up with 7 minus 3x on the right side. Now, x plus 1 times x plus 1 is... now, I'm going to teach you two ways, okay? First thing, you could FOIL it. X times x, x squared. X times 1, 1x. 1 times x, 1x. 1 times 1, 1. Equals 7 minus 6. That's one way. Or, what I prefer to do is create a box. Write them separately. The first term is x, the second term is plus 1. Here this is the same thing, x and plus 1. Now multiply each separately. X times x, x squared. X times 1, 1x. X times 1, 1x. 1 times 1, 1. That's the same thing that I have here. X squared plus x plus 1. Same thing. You get x squared, 1x plus 1x is 2x, plus 1 equals 7 minus 3x. You get one side equal to 0. So you get x squared plus 5x minus 6 equals 0. use diamond method, you get x, making it positive, so plus 6, x minus 1 equals 0, x equals negative 6, x equals positive 1. Plug it back in, see which one is extraneous and see which one is not extraneous. Question 7. One thing here is that if you're given two radicals, isolate one of them, meaning like separate them. That's what I want to do, separate them. So I get square root of 4x minus 3 equals 9 minus 2x. Square root of that, square both the sides. 4x minus 3 equals 9 minus 2x. Solve for x. And then plug it in to see if there's any extraneous. Question 8. Subtract 7 first. Cube root of 4x squared equals 4. Now do the opposite step, right? Inverse operations. So I would first cube it. So 4x squared equals 64. Divide by 4. X squared equals 16. Square root. X equals positive negative 4. That is my answer. Plug it back in to see if they're extraneous or not. Now question 9. I noticed one thing is that it's shifted right 1 and up 1. So looking at this, I can eliminate this because it's shifting left. I can eliminate this because it's also shifting left. It's either this or this. Now if I look at this, the value of 2 they're saying should be 3, but this is saying the value of 2 should be 2. So if I plug in 2 and I get 3, this is going to be my answer. If I plug in 2 and I get 2, I should get this. So 2 minus 1 is 1, square root of 1 is 1, 1 times 2 is 2, 2 plus 1 is 3, so it's 8. Given the graph, figure out the equation that represents it. So first things first, how is my graph moved? So it went from 0, 0 to 1, 0. Then, 1, 1. So shifted right 1 and up 1. That's basically all of them. Now, the parent function of the graph looks like this. So this is reflected over the x-axis, right? So it's negative. So I can eliminate this, I can eliminate this. Now it's either B or D. Plug in 2, if you get 0, that's the solution. I plugged it in and I got D. Okay? You can plug it in and see what you get. Question 11. Now the simplest way I can think of is plug it in, okay? If I plug in 1, negative 4 plus 16 plus 2. It is 14. Now is at the highest though. Plug in 2. 2 squared is 4. 4 times 4 is negative 16 plus 32 plus 2, which is 18. So this is my new highest, right? Plug in 3. 3 squared is 9. 9 times 4 is 36. 3 times 16 is 48 plus 2. That is 14, not 10, right? So that doesn't work. So the highest is 18. So it's B. I mean, turns out C is the same thing, but it's only one of them. I think I just put the same options again mistakenly. Alrighty, unit 4. I'm gonna do all the things here itself, so it's just one video, so it's easier to upload. F of g of x. See, g is inside f, so you're gonna have to write this instead of x here. So 2, I see an x, so I'm going to replace that with square root of x minus 5 plus 3, and I'm done. That's it. No more simplification needed. Plug in 9. 9 minus 5, 4. Square root of 4, 2. 2 times 2, 4. 4 plus 3, 7. The volume of a cone is pi r square h over 3. They are asking you to solve for r. So first things first, isolate this right here by undoing everything. So this is divided by 3. I would times by 3 first. 3v equals pi r square h. This is being multiplied by r square, so I would divide by pi times h and then square root it. So square root of 3 times v over pi times h equals r. That's the answer. To find the inverse, first of all, swap x and y always, then solve for y, right? So add 1 and then cube root it. So that's how you solve for y, and that's the answer. Here swap x and y again, so y equals 2x plus 3 over 2. That's the original equation. Swap x and y, so x equals 2y plus 3 over 2 times 2, so 2x equals 2y plus 3. Subtract 3, divide by 2, and that's your inverse. Now find f of x minus g of x. F of x is this, g of x. Now one thing I've seen is that people just simply write it. Instead I would want you to create a parenthesis so you can remember that you're supposed to distribute the negative. You're supposed to distribute the negative, so you get x cubed minus 2x squared plus x minus 4 minus 2x cubed plus 3x squared plus 4x minus 1. And now you can, x cubed minus 2x cubed is negative x cubed, minus 2x squared plus 3x squared is plus x squared, plus x plus 4x is plus 5x minus 5. That's the answer. Alright, unit 5, exponential. For decaying material, the amount is whatever. What you would have to do is, you're supposed to isolate the t by, sorry, not isolate it, get rid of this 8 by rooting it, okay? See how rules of exponent still applies. The denominator becomes the radical. So you can use a calculator for this, and I think you will get B as your answer. Question 2. An erosion model begins with 400, so let's say 400, that's your initial value. The amount of sand decreases by 25%, so its new value is 0.75 of the previous one every 10 days, so D over 10, and that's your answer, or T over 10 if you want. Which of the following is true about the functions? About the function this? The graph shows growth. No, it's not. It's less than 1. It's not growth. It is decay. The graph passes through point -6, 0. No, it doesn't. It doesn't even touch the x-axis, so it's not even possible. The graph has an asymptote y equals 0. Exactly. It has an asymptote y equals 0, meaning if I graph it, it has an asymptote here. It goes through this and plug in 0, so the y-intercept is -6. Sorry, you don't know how the graph is, never mind. But there's an asymptote here. Actually, if you graph it, it should look like this, because it's reflected over the x-axis, right? But that's going to be a unit on in January, reflections of exponential functions. Complete the table. You can graph it, okay? It's easy. You can graph it. Just graph this way and make sure you graph the asymptote. This is 1. You can graph it. Plug in the values. State the domain and range of the function. Domain is going to be -infinity, infinity, because you can plug in whatever you want. Range is going to be 0, infinity, since you cannot get values less than 0, and it's going to go up forever. And behavior, as x goes to -infinity, y goes to 0, it's not going to touch it. As x goes to infinity, y is going to infinity. Which of the following is true about the function this? Why is this repeated? That's weird. Same question. No, but this one, no, it's the same question repeated. Alright, that's it. That's the end of the video for all of this thing. Yep.